Audio Jungle.
Let us enter into this R session, R programming session. Okay, so we have so many kind of programming languages, right? We have C, we have Java, we have Python, we have MATLAB. MATLAB is also considered as a programming language nowadays. So we have all sort of these things. But apart from that, then why are we going for R? So what is R? What is the power of R? What are the applications of R? And who are basically using R? So I'll give a quick thing about all these things with a little bit small introduction to R, where I can use like how to install R and how to open R. So all sort of things we'll have a quick demo within this. The coming 30 minutes what we have, we'll discuss upon all these things. So if you have any queries, you can shoot me your question in the chat window so that I just look into this chat, or else you can store the questions for yourself so that at the end of the session I'll be we'll have a very good discussions at that particular point. Okay, so let us enter into this particular area. Now, what is basically R? Okay, so the very first thing what we'll be getting into mind looking into R is, okay, we have something called as C, or so is that R also equivalent to C? Or else we have something like Java. Is this R also equivalent to Java? And we have something called Python. Is that also equivalent to this? Then why do they basically call it as R? Okay, so we'll see like about the history of all this things. So R is basically a statistical programming language where this is specifically used whether you're doing some data analytics kind of a thing, some modeling kind of a thing, which is related to a pure mathematical kind of a background. So now you should be getting it out. Okay, Pawan, even C is used for it, even Python is used for it. Now, how is this R coming out of all those things? Okay, so what are the specific features what you have in R? So just hold on your questions at this particular moment. In the remaining next sessions, in the remaining slides, all your questions will be cleared. Okay, so it is also like all other things. R is also an open source package, so you can freely download from the R CRAN. You can install it and you can start working on it. You can start shooting your programs onto it. And it is one of the powerful programming language. So this point, powerful programming language or powerful writing programs, all these things will make sense when you basically start writing a particular code, comparing with R and all other languages. And at this moment, you just rely on this point. You just believe in me, saying that R is one of the powerful languages. So the way of writing the programming, a specific program in R is simple. So the structure is very easy. The syntaxes are easy. So likewise, how you write a normal text, you can directly write into it. So there are no specific there are no detailed kind of syntaxes what you need to follow. So there are no you need not worry about all those things. So R will take care about all those things. And just to make our things much more easier, the process much more easier, we have a set of built-in functions which have been there in your program, in your R programming language. So at this moment, forget about what you mean by a function. If you have any knowledge on prior knowledge on programming, prior knowledge on C, Java, or Python, then you can understand what you mean by a function. Or else, if you are completely new to this, no need to worry. But as of now, you just try to understand. Function is nothing but uh, it is just like a small, I'll not use this word, but just for our understanding, I'll be bringing it. It's a small kind of an app or a small kind of an application, what I write in R. So instead of writing the code again and again, so I'll write this code into a specific set, I'll store it in terms of a function in my working directory. So whenever I want to get back the functionality of what I used, I'll call the function. So this is what is just a crisp meaning of a function. So these things will be having, will be going into much more detail when we go for the further sessions. But as of the introductory session, we'll just try to understand at this point only. So there are so many hundreds of built-in functions. So you need not worry about to write a specific function. You need not worry about writing the code for it, the specific syntax, like the logic for it. You need not worry about writing it. So already it is there. You can call those things and you can start working it. So the main advantage of this is it makes our process very easy. So you need not worry about writing a code, calling it, saving it. So you need not worry. Just call the code, run it. That's it. Just call and use it. That is one feature what you have in R. Okay. And The next point, this is very important. So contributed package expand the functionality to cutting edge research. So this is a very important point. Why I specifically keep at this point, right? Like there are different applications of R. So R is in the next slides. We see what are the different applications what we have in R. So each and every application, there are some set of functions which have been already developed. So they are already developed and kept in name of a package. So those are known as packages. All the set of functions what you have, the club of functions or else a bag of functions, all these things are called as packages. So for your application, for example, if you want to work on business intelligence kind of thing, so you want to work on BI kind of thing. So there is a package called as Shiny. So you can use that Shiny package. And if at all you want to work on images and like high-end images, you want to work it. So there are some specific packages called as Ryoja, and so like there are some sort of like hundreds of packages what we have. So you can download that package and just install the package into your system, and whenever you are writing it, just import it. That's it. So that is the only small procedure. So using for the first time, download the package, install the package. That's it. So that is one time. Once you have done it, so that is fine. We do not worry about the next times. So whenever you want to use it, just import the package. That's it. Search what you do, what kind of different things what you do, so you have your functionalities, whatever. So let me quickly go to the next slide. I guess all the points that are there in the slide made me some sense about R, a little bit introduction to R. Okay, so this point I want to, the next two slides what I have, I want to basically show what are the different applications areas of R. So what different applications I have in R, right? So I have so-called Bayesian interference. So that is there for clinical trials, for cluster analysis. This is very important thing for cluster analysis and for computational physics and for differential equations and for environmental studies. So environmental studies in the sense people basically try to create some specific models. So you can simply write your model. You can, like, if you have your algorithm in your mind, so directly jog onto this particular R and just start typing your algorithm. That's it. That's I'm just telling this one with my experience, okay? Because I basically work on this kind of an algorithms, all sort of things. And into finance, because R, as we have discussed in the very first introduction, I've said R is a statistical programming language. So all the mathematics and all the statistical terms what you have, so R is best for it. So obviously finance comes under all those things, right? And graphical models what you have, you can do it. And graphics and visualization, like for example, you have written a model, you have created your algorithm, you have given your data to it, and you want to display it to your clients, okay? And or else you want to display it to, after completion of it, you want to see like what exactly has happened there. So there you can use your graphics, there you can use your visualizations. So there, that is the importance where you'll be getting use of graphics and visualization. So writing in R is very easy. Creating graphs and showing your images or showing your data, it is very easy, right? High performance computing, because R programming is light programming. So light programming in the sense it's easy to write, and computationally the cost of computations is very less and the performance is very high, right? So there is always a trade-off between the cost and performance. So this like the weight of R programming is less and the performance is high. So that is the reason why people like engineers, they basically work, or like people who work on high performance computing and also for parallel computing, they go for R and also Python. Okay, so these are the two different things what you basically have there. And the next three or four points are very easy, very important kind of a thing for functions, some specific algorithms, some specific standard algorithms which work with a very high accuracy with high performance in computing. So all those things, like for example, you have your SVMs and you have your decision trees. So all those kind of algorithms are best for running in R. Okay, so there your machine learning will be coming. Your neural networks, artificial neural networks. So all those things, machine learning, all those things, the R is very good. And for medical imaging, I don't want to exactly use this medical imaging. So all sort of imaging is what you have. It could be medical imaging, it could be any kind of an imaging. So working on images, like performing image processing. and also performing signal processing. It's very easy in writing in R. So the code what you write, the statistics, because all the things in mathematics, what happens in the background, right? And R is a mathematics related kind of a software. So like a programming language, so obviously you have a very good performance there. And the multivariate statistics, natural language processing, NLP. So there are specific packages also for NLP and optimizations, because, for example, if you are working on a model and you want to optimize your model, so you can do your optimizations with a very much ease in R. Okay, so these are what the applications of R. I don't say these are only the applications; these are the major applications of R. Who are basically using R? Okay, so who are the basic audience? The main area, the main people, the focus where R is being used. So your Microsoft, they are using R. Your Facebook, Yahoo, Google. So all these are the list of the companies what I have kept that goes on to infinite. But I just place some major clients, the major chains who are basically using R. Okay, so your Microsoft, Facebook, your Yahoo, Google, Ford. So Ford Motor Company uses R for developing, for creating some statistical analysis inside their, like internally they are basically using it. So Bank of America, so they are using it for their accounts and also for reporting purpose they are using. So even New York Times is also using for reporting. And Mozilla is used, Mozilla and Twitter, all these and Uber. So these are all, now if you can look into this companies, the list of companies, there is also a specific meaning in the background. Okay, my main intention of having only these things in the background is all these companies are data, they use lot of data and they create lot of data, right? So if you can see Microsoft, Facebook, you will have like thousands of posts coming each and like every hour, and Twitter like some per day like some millions of posts will be coming, and Mozilla like every day some hundreds and lakhs of users are basically using their web browser. So many people are coming into it and coming out of it. So they need to have a log of it, right? And Ford Motor Company, that is one of the biggest chains in motor in automotive industry, and they have their own different kind of subsequent branches on some different applications. So all these companies, they generate a lot of data. Like they generate some TBs of data every day. And how do they process such a kind of a thing? So for processing all those things, they basically use R. Okay, I don't say they use only R. So R is one of the tool what they use for working on those kind of a thing, for those data. Apart from that, they also use Hadoop. That is secondary. Okay, I don't want to discuss about those things, but I want to highlight R here. So R is one of the tool. I'll not say that is only the tool. It is one of the tool what they use for processing some data, for huge kind of a data. So these are what the major companies. So I've said you at the starting of this slide. So these are the major companies, and likewise there are hundreds and hundreds of companies using R every day. Right? So this is about the major people who are basically using R. Okay. So till now, from the last 15 to 20 minutes, we have discussed about what is R. Okay. We have seen about what are the different applications of R and what are the different users of R, and we have also seen about who are basically using R, right? So these are what a little bit introduction kind of a thing. From this, we'll just try, continue with about how to install R and how to invoke R and how to write your programs using R. Okay, so till now we had, I guess we had very good kind of an introduction. So if you that's really good. So we'll move into the next slides about how to install R and how to use basically R. Okay, so how till now we have discussed about R like 100 or 1,000 times I would have said R. Now from where I will be getting that, how do I install it, and how do I invoke it, and how do I use it? So this slide basically gives you some light about how to use it. So where you will be getting R. So you can download R from rproject.org. So there are specific dedicated teams working on R. So R team, they will be working on it. And you can download your CRAN from it. So if at all we are in India, so to work to download it, you need to get it from IIT Madras. Okay, so that is the CRAN which is there in Indian region. So they're basically having like IIT Madras. There's specific group, so they are basically supporting this kind of a thing. So you can select you can download your CAN, you can select your mirrors. So your mirror, it will be IIT Madras. Then you can select like onto what version. So if at all you're using Windows, yes, R supports in Windows. If at all you are using in Linux, yes, R is also there in Linux. If at all you are into iOS, yes, R is also there in iOS. So depending, so platforms, it is not a platform specific kind of a thing. So it might be of any platform. If you write an R code, that if at all you have written an R code in using Windows, so that it also runs in Linux, it also runs in iOS. So it is not platform specific. Okay, so this is a very important point what you have. Then you need to select your base. So this is the base is nothing but the standard thing what you have, the standard R setup what you have. So depending upon the what version you want to use, you can select your R versions. If at all you are having a 32-bit system, then you need to select your 32-bit executable file. If at all you are using a 64-bit, then you can use a 64-bit executable file. So these are what this is the specific way of downloading. Likewise, how you download any other software or any other applications from your internet base. So in that way you can download it and you can install it. So that is fine. So that is okay with you, right? So as of this moment, I only talk about the base versions of what you have in R. So apart from base, there is also some specific GUI kind of a thing what you have. So that is, you call it as R Studio. So that is likewise for working in R Studio is nothing but it is much more graphically, it's very good. Like, okay, so um, I guess you'll get some very good idea when I talk about those things later in the next slides. You'll be getting a very good idea about it. But as of now, we just try to understand there is also something called as R Studio, where this R Studio will be running on the R base. Okay, so onto the R base, this R Studio will be running, and this R Studio will interact with your R base, and this R base will interact with the R core, which is there in the background. So there is a specific hierarchy what you have. So like if at all you want to use your mouse very much, then you can go for R Studio. Or else, no, I'm not a mouse kind of a user. I'm a strict programmer. I only work on command prompt kind of a thing. Then RBase is much more enough for people who are using this kind of thing. Now, this is the R GUI what you'll get. So this is the standard R base what you have. So here you can see whenever R starts, so what is the foundation what you have, it will be giving it. And so this is about a small introduction part what you have in this R kind of thing. So whenever R opens, this is the standard base what you'll be having, what you'll be looking into this particular thing. Now, if you can remember, I've said something called as packages. So to install a package, so for example, if you want to work on business intelligence kind of a thing, right? So for business intelligence, so there are some set of functions where those set of functions will only be used when I have the package installed in my computer. So that means the package must be there inside my R code. So to get those packages, just click on packages and select the CRAN what you have, and from the list of packages, we can directly install the package. So that is very easy. That's very simple. So I think the time what I've taken to explain it is very much bigger compared to the process what we do it. So that is the ease of using R, and that is what is the best feature what you have in it. So installing packages is very easy. You have already, the list has been given there. So from that list, you select what package you want and select the CRAN, select the mirror, and that will be installed. That's it. When you have installed it, then you can import those things. So let us slowly move into the next slides. Wherein now that we are going much more. I'll not say we have been into the deeper part of R. So we are just at the threshold of entering into R. Okay, so we have just entered into the room where you have R. We have just entered. So we'll see like further when I move much more deeper. So I guess R will be very much interesting for you people. So whenever you want, I can guarantee you that R will be much more. I'm not able to get the exact word what I said. So it will be much more helpful, much more easier to understand, and much more fun. So we'll have a lot of fun working on this. Right. So let me go to the previous slide. So in this slide, what you have now, you can see there is something and red color cursor there, right? So this is nothing but likewise how you have your command prompt. So you write your command, enter your command, that will be executed. So it is a step-by-step execution. So interpretation is whereby it is interpreted language. So you will have your step-by-step executions here at this when you write in this console. So we will enter into the technical terms of R. Okay. So I'll not use something called as command window or all those kind of things. So we'll call it as console. Okay. So in R it is known as console. Okay. So in the console you will be writing your commands and that command will be executed directly. So directly you write your command, that will be executed. But sometimes you have your program in such a way. So you have your program in such a way. So it is around like 10 to 15 lines, or it's 100 lines, or it's 120 or 150 lines code you have. Okay. So now how do I write those 159 codes? So you should be getting it out. When you said each and every step that will be executing. Now, how can I write my conditions and all sort kind of things? So, I don't want my code to be executed until I write it till the end. So, until I complete it, I don't want my code to be executed. Now, is there any feature what the R is supporting? If you ask me that question, I'll definitely say yes. There is something called as script files what you have. So you can open your scripts in R. So in the next slide, it is like this. So you can open your script, just click on file and click on new script. So that new script will open a text file kind of a window, so an editor window. So here you can type your R code. Okay. So irrespective of it being executed, so that will be a type. So you can type your complete code and you can save your code at a specific location, and then you can start running on. You can start running that particular code. Okay. So this is what about how to write my code in my console and also in my editor. So there you can do it in two different ways: writing in your console or else writing in your editor. So there are the two different things what you have, and you can save these on like if you are writing a code and you can save it into your some specific locations, and that specific locations you can go to that specific location. You can start running on that particular one. So these are about how you write your code and how you basically work on that particular code. Right. So now we'll move into some programming concepts of R. Okay. We'll enter into something called as programming concept in R. So like what are the different features what I have in R, and what are the different operators and all sort of things. What are there in this R? We'll be looking into in the next slides. In the next 10 or 15 slides, we'll be seeing all those things. Okay. So the very first thing, because whenever I've started learning R, or whenever I've opened R, so we are not masters of it, right? So at the very first thing, when I start typing it, my question is now, what should I type? What should I do? And like some of like you people, if at all you have an instructor like me, now that instructor, he'll be saying that okay, you type something, you work on a specific function called as you work on the specific function called as what in this example, let me say histogram. So there in that specific function like histogram and sort of the things. So you'll be you need to have that particular thing, right? Now you need to understand like what it is. Now, what is that histogram and all this you can understand, right? So there to get information about a specific function. So the help is very easy. So you just put a question mark before the function there and just execute it. So you'll be getting all the information about that particular thing. So that is one beauty of R. So like for the very first time users, or else if at all you are working on a specific package which you have not worked before, so in that package there are specific functions and you want to know about that function, right? So to know about those kind of functions, about all those things, then you can go for this this help kind of a thing. So just put an question mark and before the function, and you have it. Apart from that, you have very good documentation which is already given in the R project website. So you just go to that website. So there are specific documentations for your how to write your programs and all those things. So you have your documentation there. Apart from that, each and every package what you installed, so all those things are there in their own specific web pages, right? So each and every package what you install, so there is a specific documentation file attached with it. So you can download the documentation file and all the functions what you have. So all the functions what are there in those particular package. So those they'll already be listed there from that list, you can see the syntax, you can see an application of it. So the documentation part is very good compared to R. So any questions what you have, or any doubts what you have, or else if you have any issues working on with a specific package, or else you're stuck at a particular point and you don't know like what should I use and how should I go for the further thing in the next things. So for all those things, you have very good documentations there here. So you need not worry about the documentations or else any other issues or technical issues related to it. So the only thing what you need to worry is the logic what you write, because the logic what you write, it is there only with you. So you need to only worry about the logic what you've done. That's it. So apart from that, you need not worry about anything. So you'll be having a very good documentation part and support. So support is very good in terms of R. Okay. So now, that in this phase of our journey about learning about R, we have installed our R, okay, and I guess from my as of now we are not having any hands-on kind of a session. So I guess you have learned about how to install R, and you have learned about how to install your packages. So you have also seen about how to learn about how to use your packages, and apart from that, you have also learned about how to set your windows up, like whether you want to work on console or else you want to go for a script, all those things. So all those things is ready now. Now that the setup is ready and you are ready for it, right? Now we are just ready to enter into this programming point. Now the very first question what it comes at this point is, now how do I bring data into my R environment? So whatever we do, that is on data, right? So if at all I want to work on some statistical analysis, so obviously I need to have some data with me. I need to obviously have some file with me, or else I need to have some structured, or forget about what types of data. I'll not talk about all those things. So we need to have some data into my thing, right? Right now. That data I'll be working on in my R. So there I'll be performing some specific statistical analysis, or else any sort of analysis. So if you can look at this point, now we can see there is something, a file, we have assigned alphabet here, and we have seen a specific, unlike you people, you can see here, right? So you can see the specific arrow mark kind of a thing. We'll see about all these things in detail, and you have also seen something like this, and so this is what by using the code you are just trying to bring your data here. So the meaning of this point is, so this is very simple. So you read a table, so basically you're reading a table, so the syntax for it, read dot table, and open the bracket and close the bracket. So this is a very important point when writing a programming. So this is one important tip in writing a programming. So whenever you open a parenthesis, then you need to like open a bracket or any parenthesis. The good programming practice, immediately close the parenthesis, and whatever you write, obviously that will be there in between these things, right? So then you can start writing about all these things here. Because what happens is, normally we'll be thinking only about the logic, and we'll be having some hurry to write it. So we'll tend to forget to put this particular point at the end. So that will throw you syntax errors. So to get rid of all those human errors, what we basically do it. So we'll take our own precautions. So open the bracket and close the bracket, and here you give the path. Now the very first argument that goes into it, it is nothing but the path. Now, in that, the path here is, where is your file located on your computer? Okay. So what is the, in what location it is? Now give the path there, and here we are just trying to copy to bring the CSV format file. So the comma separated value formats. So obviously, if it is a comma separated value, the sep is nothing but the separator what I have. So the separator, it is comma, right? So I'll have my comma, right? So this is the separator what I have. So the separator where my columns have been separated or my data is separated is being done by this comma. There I'll be using my comma. Then you give your header is equal to true. I'll discuss about this header is equal to true in the next slide, like in the next sessions when we go into a little bit deeper. So I don't want to make a mess at this point, but just at this stage you just try to understand. Now you have read your table and the location is ready, right? And to bring that into your R environment, that data must be stored in specific location in your R environment, right? So this is very simple. Like you have bought 10 kgs of rice from your shop, okay, and you have bought into your home. Now this is what is the way you are creating. So ask dot shopkeeper rice comma, how many 5 cages, and these arguments are a little bit, I don't want to discuss about those things at this stage. So you have done all these things. Now you have asked your shopkeeper, and you have bought your rice, around like 10 kgs of rice you have bought. And that rice, so whenever you have bought that rice, it is obvious that you will be storing in your house. So that is, this is nothing but it is showing that bring the rice into your house environment. Okay, so from the shop, so this is the shop environment what you have. So from the shop environment, bring that into your home. Okay, so you are bringing your rice into your home, and this symbol. So these are what the operators. So this is nothing but assigning operator. So whatever it is there on the right hand side, that will be assigned into your left hand side. Now that you have bought into your house, like you have bought rice into your house, now where will you store your rice? Where will you put your rice? Will you put it in your kitchen, or will you put it in your bedroom, or will you put it in your master in your hall? So where are you basically putting it? So you give the point where you are storing it. Now, rice will obviously be there in kitchen. So there is no meaning of putting rice in our bedroom. So rice, it is put in your kitchen. So in the same way, you create a variable in your R environment where that data, what you are bringing it, that will be stored into this particular variable in your R environment. So this is how you bring your data into your R environment. Right? So this is how we basically try to import your data, and this is about the importing data what you have. So we'll quickly move into the next slides. I want to work with my R, so it is there in my variable, right? So I need to fetch my data into it. So I need to access the data from a particular thing there. So these are what the specific syntaxes what I'll be using for accessing a particular column. So D is nothing but the variable where my data has been stored, right? So if at all I want to select a specific column, so use the D there, use the variable where your data has been stored, and use this dollar symbol. So this is nothing but the connector kind of a thing. So I want to access a column which is there in data, which is there in the variable D. Now to connect both the things, I'll use this symbol. So I'll use this dollar symbol for it, right? So this is how we basically access the data from your environment. So you cannot you cannot directly see the data what is there in the column until unless you open it. Now I don't want to open my data. Okay, I don't want to open what is there in my data. I know that there are some specific columns because whatever data what you are bringing into your R environment, it's obvious that you have some idea about how to use what is there in that particular data, right? So I want to access some columns from my data. So this is the syntax what it basically follows. So use the D, put the dollar symbol, and use the column what you have. So or access the column number, or else access the row, or else access an element, whatever it could be. So you can access your data from your particular R environment, right? And moving into, because these are what the standard things what we go whenever we try to learn about R. Because if we can understand about all these things, then we can directly jog into writing like doing some hands-on kind of a sessions and all this kind of things. Right? Okay. So we are moving a little bit further. So I have got my data, and I need to see. Sometimes it happens in such a way that your data will be very big. It's a huge kind of a data. Now, if those kind of a data, now I need to basically subset my data, right? So what I will do, I'll subset my data, and I'll work only on that specific data element what I have. What is basically I wanted. So I'll be working on those particular things, and I'll be using this particular thing. So that is subsetting kind of data. We'll see about how to subset this data in the next sessions. So there you will have a very good understanding about how to use all this, because as an introductory kind of session, I'm just theoretically explaining about all the things what you have. And you can use the next thing is very important. So all the logical operators what you have, like I have two variables, like I have two data stored in variable A and which has been stored in variable B. Now I can use all sort of logical operators between them, like equal to operator. So like if A is like logical equal to, it is always two times of equal. So one time if you are using only single equal, so that is nothing but assignment operator. It becomes an assignment operator. Now this is a logical operator. So if at all it is exactly equal, then it will be showing whether it is true or false. All those sort of logical expressions what you basically have. So you have your greater than, less than equal, greater than equal, and all sort of logical operators what you basically have. And this is how you basically try to get your data uh, an example of using logical equal. So here we have something called as D. So D is nothing but the data where I have my data, right? And gender is nothing but some column value what I have. Okay, so I have a column value and I have a gender D value, and I want to see whether if it is equal to male. So this M is nothing but this is an a thing like this is an a value which is there in the gender column. Okay, so if at all if that is equal, then it will be giving me an answer. So this is how we basically try to access your logical operators. And this point, what we have is very important. R is case sensitive. So this is purely case sensitive. Like in this, like if at all I want to, maybe I have. Okay, so this is very simple. So case sensitive in the sense, I guess you can understand about how do you what do you mean by case sensitive here. Now, for example, I have created an variable d. So if it is a small d, so that is one variable I have. If it is capital D, then there is another variable. Like normally, what people do, what people make some mistakes is they'll assign the variable to a specific small letter or else a capital letter kind of a thing, and they'll be using opposite to access the data. So obviously that is not happening because this is case sensitive. So if at all you're changing the small or capital kind of things, the variable name will be completely changing. This is a very, very important thing. R is a case sensitive kind of a programming language because the advantage of having a case sensitive kind of a programming language is you'll be having so many words to create some functions. So you have so many kind of words, you have so many alphabets, you have so many letters to create functions to store data. So there is so if at all it is in case insensitive data. So if at all I've used D, then D is blocked. Small d, capital D is blocked. And if at all I'm using my variable as pawan, okay, if at all small p a b a n, if that is a variable, then the word pawan is blocked. Now, if at all it's in case sensitive, then all small p a b n, that is one variable. All capital P a b a n's, that is another variable. Starting with capital P and all having all the different small letters what you have. So all these are different variables what you have. So there you have a lot of scope of creating variables. Like for each and every positives, obviously they'll be having a negative, right? The main negative with case sensitivity is a lot of people tend to confuse a lot of about it. So that's obvious. We'll get confused with small d, capital D, small common, capital common. So all those kind of things. So you need to be a little bit careful while writing variables or else assigning variables or else calling the functions. So even calling the functions is also case sensitive. That is why I just try to warn at the initial stages when you start programming at this point. Right. So these are what different things what we basically have. So these are what some basic precautions I just want to show. Okay. So likewise whenever we see something, there will be some disclaimer, right? So exactly this is what exactly what I want to say. So please be very sure that whatever you are trying to write, whatever you do in R, it is case sensitive. Okay. So like the main use of using R is for graphics. So you have a lot of graphics which have been involved there, and you can write actually if you can recollect, like now you can this is what is something called as a function. Now I've said you in the previous things, like you have your functions which has been there in your R environment. So hist is a function. So the functionality of that function is creating a histogram. Okay. So if at all you want to create a histogram of a data element, then use this so-called function called as hist. So use hist and okay. And what you want to plot in your histogram, so give that variable in the brackets. Okay. And this is nothing but now you can see T is the data where I have my all my data which is being stored in variable D, and I want to access a specific column or it's a specific value or it's a specific title in my data, and I want to plot it in my histogram, right? So for that I have my histogram of D dollar symbol. That means you are accessing a variable called as or an element called as WG from the variable D. Okay, so this is how we basically try to create your histograms of it, and that will plot a histogram for the data what you have. Okay, this is very simple. So this is how Now, this is one beauty of writing, creating R plots on all this. So you need not worry about writing a function for, like writing a code for plotting all this. So you need not worry about all this. So you have your functions which are already there, which are inbuilt in your MATLAB environment, that you can directly use it. Right? And so that now we have plotted our thing. So we will try to add some titles also for it, right? So this is only a standard histogram what I have. Now I want to add some titles to it. So sorry, I'm just going back. Okay, so to add a title, so this is what is a histogram, like hist of function. So this is, so the title goes as an argument. So the main, so main is the name of that plot what you have. So you give the plot name as weight gain. So here in this case it is weight gain, and you calculate it. So these are this is about how to plot your data and give the names for it. And you can also give your access. So access values is also like this. So the first argument which goes is the variable where you have your data. The next argument is the main name of that particular thing. Then xlab and ylab are nothing but x labels and y labels. So now we can see weight gain, it is in x label, and that has been exactly there in my x axis. And frequency is nothing but y label, it is there in my y axis. Now this is a complete picture, right? So without frequency and without the names, the plot looks completely insufficient. So there is no meaning of drawing some plots without any names. So this is from all these things. And very important point at this stage is all the things are going into your histogram, okay, into your data point what you have. That means into your function. So all these are going as an arguments into your function. This is a very important point, right? So like the normal mistakes what we do is we plot hist of the of dollar value and we'll be closing it, and then next we'll be giving the label values. No, that is not acceptable in R. So all the things what you goes, all the variables what you goes into your histogram, that will be going into the histogram there. Okay. So this is how we basically try to create your plots. Now you can also try to add some colors to it. Okay. So different colors what you have in R, so you can specify the color value also. So this is nothing but we have tried to add one more argument to it. So these are like you are trying to increase the complexity of your graph. And one point here I just want to talk about this function is the very first value what you are giving. So the very first value that goes into your function, so that is the standard, that is the variable where your data goes into it, and all the remaining things are nothing but arguments what we call. So arguments are nothing but, they are not 100% compulsory whenever you want to have. So if at all you want to use, the default values will be taken care of. So you need not worry about giving the value. So until unless you specifically you want it to be there. So if at all you don't want to care about all those things, forget about that. So the default values will be taken care of. So the default, the color will be white, and x label, you will not have your x label, y label, and the head of the function head will be the variable what you have plotted. That's it. So these are what the things what you have in your plotting. And since R is a statistical tool, a mathematical tool, so plots are very important for all the mathematical operations, or else all the mathematical functions what you do in your programming. So so this kind of graphics R supports very good support for your graphics. Okay. So you can load your complex images. You can load into your R environment, and you can start working on it. So you'll be also having an interactive kind of a session in R, where you can interactively capture some elements from my R. So there are all different functions which are assigned to it. So simply call that function, give the variables into it, that particular thing, and you can start working on that particular thing. Right. So these are what the different colors what we have, and apart from that, there are different plots. So till this is one kind of a plot, histogram. You have your box plots, okay, because statistics, whenever I say that, they will be having a lot of things which goes into my plots. So we have, so R is supporting for histograms, box plots, stem plots, and you can also have for your board plots. So all these kind of different kind of plottings, what basically goes for statistical analysis. So all those plots are 100% supported by your R. So this is what about the plots, different kinds of plots what you have. And similarly, what I can do is I can plot two different plots into a single window. Now you can see here, this is one variable which is going into my box plot here, and comma. If I give the next variable, so that is the next variable what it displays into my plotting kind of a thing, right? And one more important point I just want to discuss at this stage is all the arguments that goes into it, arguments in the sense all the text values or all the strings whatever that goes that will be going into your single quotes. So whenever there is something written in the single quotes, you should be damn sure about it, saying that okay, oh, so this is an string. So that is what. So all the extra names what you give, all the text what you give in your functions, so those are strings, and all the strings goes into single quotes. This is very important thing that goes in form of single quotes, right? So you can now we have seen only about a single plot which is going here. So you can have your multiple plots inside a single plot itself. Like in this example, what I have. So here I have plot 1 and plot 2. So both the things, instead of having two different graphs, I plotted in a single graph. So that is, we have used blocks plot of variable A and variable B. So in this way, you can write plot the different kind of plottings in your thing. Then and all these things as next things are the similar things what you have, right? So give the name, give the main goes for your name and X label. So the main, the first value and the second value. So this first column and second column value names. So in this way, you can try to give different names for the box plot and all those things. So similarly, you can have much more complex kind of things into this particular thing. So instead of having a single plot, I can have multiple plots also. So for one plot and two plots and multiple plots. So similarly, likewise, when you go for your plotting there, you'll also have your scatter plots. So scatter plots are very important in the sense whenever I want to see this distribution of data into my space. Okay, I have my data which has been spread over my area, and I want to see the distribution of it. So to see the distribution of my data points and everything, I go for my scatter plots. So these are about the different kind of scatter plots what I have in my. And also you have something called as line plots. So line plots are nothing but the data what in the format of lines, those will be you'll be having here. So these are about the different kind of plots what you have, and as I've said, R is a mathematical statistical programming language. So the graph options what we have, that will be the best options for it. So like all the math, the plotting and all those things what your statistics is basically having. So exactly the same thing R is also being for.